Let's get back here. So I can actually tell you right now that this is going to converge. And the reason that I know it's going to converge is because at the end of the day, I'm going to be replacing these numbers in here, these x's, with t's, right? And those t's are going to become 4s, aren't they? Okay, so when this becomes a 4, this can become 0. And 0 to the 5/3 is just 0. And then 0 to the 2/3 is just 0. So nothing's going to become infinite. Do y'all see that? Yeah. What would have been a problem, though, I would have known it was going to diverge had one of these been a negative exponent. Because then when you take 0 to a negative, it's really 1 over that, right? And then you would have division by 0, and that thing would blow up. It would get infinite. So I can already tell you right now it's going to converge. But I still need to show it. And if it's going to converge, then I need to figure out what it converges to. So limit t approaches 4 from the left. All right. I'm just wondering how much I want to write here. Okay, 3/5 x minus 4 to the 5/3 plus 6 x minus 4 to the 2/3. Then my evaluation bar is going to go from 3 to t. Okay, so I'll do that. And then I do plus another limit. This time r is going to go to 4 from the right. And then I'm going to have 3/5 x minus 4 to the 5/3 plus 6, and then x minus 4 to the 2/3. And then my evaluation bar is going to go from r to 5. This is all going bye-bye here. So maybe it's a whole nother layer of pasta. I don't know. Maybe it's not just oregano. Equals limit t goes to 4 from the left. And then we're going to have two things in here. And then plus another limit. This time r is going to go to 4 from the right. And then we're going to have two things in there. Yep. All right, when we put the t in here, we just replace all our x's with t's. Then we replace all of our x's with 3's. Come on. Then on this one, we replace all of our x's with 5, and then all of our x's with r. I hope y'all can see that. I'm running out of room. Three-fifths. I'm replacing it with r. R minus 4 to the 5/3 plus 6 times r minus 4 to the 2/3. All right. Now normally I try and figure out what all the numbers are and then go take the limit. But I'm actually going to do the limit first because the limit's going to kill a bunch of stuff off. So if t approaches 4 here, we said this already, that'd be 0 to this power. Because that's not a negative power, it's just 0. So this is all dead. This right here is all dead. And then over here, when we let r approach 4, oh, did it matter that we were coming in from a certain side? Like on this? Yeah. When we plug a number in here, it's becoming close to 0, right? Yeah. This is a cube root, isn't it? This means the cube root to the 5th power. When you do a cube root, you don't care if it's negative. So we don't run into any issues here at all. So actually the one-sided limit doesn't have an impact here. It's not necessary, I should say. That goes away and that goes away. Are we all clear on why those all go away? Okay.
Why do they go away?
Because we get, like, if r is going to 4, 4 minus 4 is 0, and 0 to any power is 0, and then that kills off that. And then that'll happen here. And that's what happened with the t's over there. Now, the rest of this we still have to take care of. So we have a minus sign, parentheses. All right, 3 minus 4 is negative 1. Negative 1, cube root of negative 1. What's the cube root of negative 1? Still negative 1, right? But then to the 5th power, still negative 1. So this right here is negative 1, but then times 3/5. So negative 3/5. All right, what about this? Negative 1, cube root, negative 1, squared, 1. So this is 1 times 6. Okay, plus, all right, now this one, these are nice. 5 minus 4, 1. 1 to any power is still 1. So this is just 1, so we get 3/5 there. And then over here we get plus, and then again, this is 1 times 6, so this is just 6. And we can start putting that together. Distribute the negative through over there. You get 3/5 minus 6 plus 3/5 plus 6. The 6's cancel. 3/5 and 3/5, 6/5. The area under that curve between 3 and 5 converges to 6/5. That took a little while. Do I still have more examples? There's the picture. Pardon? What? Oh, okay. Now, some of you might be looking at that right now and saying, wait a minute, our answer should probably be 0. There's a difference. And the reason why there's a difference is because the function is not symmetric over 4. Like if you go to 4, that's where we have the asymptote. But to the left of the 4 and to the right of the 4, you don't have the same picture. And it all has to do with that x right there. That x right there, if you're to the right of the 4, that x is big, right? If you're to the left of the 4, that x is smaller. So when we look at this graph, to the right of 4, this is actually higher up than this is right here, if that makes any sense. These values right here are negative, but they're not as tall like that compared to, let me see, let me go to the second one there. That compared to that one right there. So this one is a little bit taller than this one is negative. So it's...
You can see where it's at, it's below the negative,
Yeah.
negative 5, and then the other one is like right at 5.
Yeah, if I go here, just look right there, right? I'm that distance. Like I'm never that distance on that one. So I've got a little more area on this one than I do on this one, and that's why our answer is positive 6/5. It's hard to see it, but it's there. Let me see what else I have after this one. Oh, that's it? Okay. Why don't you work on this for 10 minutes? See how far you get in 10 minutes.
integration by parts.
I'm not sure yet. I haven't done it. Integration by parts sounds right. Integration by parts. What do you got? -4? Anyone else get -4? I'll give you all a few more minutes. What's that? 2 root x? There. So this becomes 2 root x minus 2 integral of 1 over.
Can you still simplify that one?
Oh, like factor something out?
Yeah.
Yep.
What if you did integration by parts?
What did I what?
What if you did the integration by parts?
You put natural log of x here, and you put 1 over root x here. Then when you integrate natural log of x, you're going to get x natural log x minus x, and that's going to be ugly. And then you're going to have to do that times this in the new integral. So it gets worse if you do it that way. Like this step gets worse when you do the voodoo. Yeah. All right, so maybe we should discuss this a little bit. We have a problem at 0.
Yes.
Okay, and that's the only problem we have. And so we have to limit as t approaches 0 from the right-hand side. We have to integrate this, so you have to do integration by parts. So here's the integration by parts. One thing I guess I would point out is that it's better to let u be natural log x because the derivative of that's 1 over x. And then this has to be 1 over root x. It cannot be root x. 1 over root x, right? And then integrate that. That comes to this. And then here's your u times v minus integral v du. So these two multiplied. The 2 comes out. Root x over x is 1 over root x. And then you have to integrate that again, and you get 2 root x, but you already had a 2. Yeah? So there's your antiderivative. Now, we are going to run into a problem over here. When you plug the antiderivative in right here and you say, okay, I'm going to evaluate it, t and 1, and then I'm going to take a limit. You plug in 1, you plug in t, this is where we are. right? Now this right here is 0 because natural log of 1 is 0. So that's 0 minus, and then this is just 4. So you get 0 minus 4 there, and then minus, okay, t is approaching 0, right? T is approaching 0. So this one right here, root 0 is 0. So that goes to 0. This is the one that we have a problem with. And that's because this is going where? To 0. But where is this one going? Negative infinity. And when you have 0 times negative infinity, that's an indeterminate form. So I need to work that out over here. So I need to ask myself this question. What is the limit as t approaches 0 from the right of, let me just do root t natural log t. I don't really need to concern myself with the 2. Okay? So what is the standard procedure if you have 0 times infinity or 0 times negative infinity? Yeah, you drop one of them down. So I'm going to leave the natural log t upstairs, and I'm going to drop the root t down as a 1 over root t. Okay? That's the same expression. But now if you let t go to 0, you get negative infinity on top, and you actually get 1 over 0. This is going to head to infinity, so you get an infinity over infinity expression, which is what you need for L'Hopital. Right? That goes to 0. Root 0 is going to 0. Fixed number over something that gets small gets big. So now I use L'Hopital's rule. And that means derivative of the top, derivative of natural log t is 1 over t, over the derivative of the bottom. Now remember, the bottom is really t to the negative 1/2, right? That's what the bottom really is. So the derivative of that is negative 1/2 t to the negative 3/2. So if you want, you could look at that as being the limit as t goes to 0 from the right of 1 over t over negative 1 over 2t to the 3/2. So I'm looking at this as a fraction by itself down here. And I left the negative 1 on top. I dropped this t down with the 2. And I did that so I have a fraction over fraction so I can flip and reciprocate that up. So this becomes 2t to the 3/2 over negative 1. That's just me flipping that and bringing it up, multiplying instead of dividing. And t to the 3/2 over t is just t to the 1/2, which is just root t. But I have a negative and I have a 2. So this is all just limit t goes to 0 from the right of negative 2 root t. And now take the limit. And what does that limit go to? 0. So this goes to 0. So yes. Now, on a test, I understand there's a lot going on here. But on a test, you can't just write this and then 0 and get it right without justifying that step. Because in my mind, I'll think that you think that 0 times infinity is 0. So you have to somehow justify why that indeterminate expression goes to 0. Because it could just as well have gone to infinity. It just depends on what these functions are doing, or like how they're composed. So our final answer is negative 4. All right, so that was the last example, And I was almost going to say before this one, I was going to say, hey, notice we haven't used L'Hopital's rule. We haven't needed it at all on these. But we needed it on this 5th one. All right. That's it. That's the whole kit and caboodle, so they say.
Where we're going and we're trying to find from negative infinity to infinity, and we have a discontinuity.
Good question. That would be like, you're asking, would I ever ask you something like this? Or would you ever get something maybe like this? I don't know.
Yeah, I like this one.
So about,
Where you have both types in one time. That question could be asked of by somebody. I won't ask you that.
but how would we go about that, because we have to put a limit for the discontinuous and
That's right. So you would have to do like 2 different limits within each one. So first you would break this up. You'd have to break it up because it's negative infinity to infinity. You have to break it into 2 pieces. And I think the most natural thing for us to do would be to go from like negative infinity to 0, right? But 0's where we have a problem, right? So you would have to do almost like a double limit. You'd have to take a limit on the left side going out and the limit on the right side approaching 0. So you might do this. Again, I wouldn't ask you to do this. What I would do is I would go maybe break it up like this. So I would go from negative infinity to negative 1, do that as its own integral. And then negative 1 to 0, do that as its own integral. Then 0 to 1, and then from 1 to infinity. But the deal on this is that if one of those diverges, the whole thing diverges. So that would happen. And in most problems, most of the time, I mean, almost in every problem that I've ever come into contact with, if you have a vertical asymptote that converges, then the horizontal asymptote is going to diverge. At least with power functions, that's the way it behaves. Except 1 over x. 1 over x diverges both ways. But I'm not going to ask you that. Yeah. All right. The homework assignment now, is there. There's the picture. -4. Makes sense that we got a negative number. Okay. So there's the homework for this. The test. I told my other class that I was going to try and come up with some sort of guide for them to get ready for the test. And I started to do that, and I realized, you know what, I don't know what I can tell you other than you're going to have to do a trigonometric substitution somewhere. At some point, you will have to do trigonometric substitution. You're going to have to complete the square, right? That's going to happen at some point. You're going to have to do partial fractions, and most likely it's going to involve you having to maybe do a long division first. So don't remember that. Don't forget that step. That you have to check the powers. So with those 2 things. Remember, with trig substitution, you have to do a trig integral. Like you have to get it all in terms of sine, cosine, whatever, tangent, secant. Then you have to do reference triangle, all that. So I'm not going to ask you a trig integral by itself, like cosine cubed times sine squared. I'm not going to ask you that on its own, because it's built into the trig substitution. So definitely a trig substitution problem. I would expect to have to complete the square in that, all right? Definitely a partial fractions problem, and I would expect to have to do long division in that, right? So that right there alone is like two or three problems maybe. Definitely a type 1 improper integral. Definitely a type 2 improper integral. So now we're up to 4 or 5 questions, right? I'm not going to ask you a definite integral, because to do improper integrals, you kind of have to do the definite integral. You know what I mean? Like you have to do the evaluation bar, plug in. So if you can do it for improper integrals, then I'm sure you can do it for just regular numbers. So, yeah. How's that for a review? I basically have told you every type problem you're going to see on the test.
Yeah.
You know?
Bonus questions or anything?
Any what?
Bonus questions or anything?
I haven't written the test, so I haven't thought of one yet, maybe, I don't know. But notice that in the problems that we did with the type 1 and the type 2, in the type 1, you had to do some L'Hopital in there, right? So you're going to need some L'Hopital. I would expect to see 0 times infinity. I would expect to possibly see infinity minus infinity. And then in the type 2, the techniques of integration come back into play. There was an integration by parts problem, right? So you might see integration by parts somewhere in this, right? I mean, it may creep up. So I felt like I was going to say something else. Oh, yes, I remember. So I was grading those take-home quizzes, and there were a few students that did number, where are they? Are there any extras? Let me see these. There are a few students that did number 2, which was the one that was the square root of 3x squared minus 4 over x. There were a few students that, I don't know, you can correct me if I'm wrong if you're one of these students, that used a method that was not used by me in class. And I said you could get help, and I have no problem with the fact that they used a different technique. The thing is, they did the problem without doing trigonometric substitution. And the danger in that is that if I add one little thing to that problem, like if I put an x term in the middle, like right in the way it shows up, it's 3x squared minus 4. But if I put 3x squared plus x minus 4, the method that they used is not going to work. So I'm a little concerned with those students that I don't think you were avoiding the trig sub, but you need to practice the trig sub. Because the problem I give you on the test, you won't have a choice. It will have to be trig sub. So I just want you to be prepared for that. That's all. Okay? Let me see. This in no way is a review. Don't be like, can I take a picture of that, sir? I did look at some of the old tests that I had, right? So, as you can see, it was, a couple of problems. Let's see what this was. Hold on. Oh, this was a different test. Okay, but at the beginning of this test, this was in spring 2015. So for this particular Cal 2 class, I broke up the exam in a different way because of how much we had covered. They started their test with improper integrals. That was the first thing on their test. So, look, ooh, wow, look at that integral. Can you all see that? You all know what that is? You know how to get that integral?
There's a formula. Is it formula 20?
Mm-hmm. It sounds like a background music while you're thinking about an answer, right? Like Jeopardy does. Da-na-na-na. That's U sub. What's U?
1 plus.
Not quite. X cubed. This is x cubed squared. Okay, x cubed squared. So if you let u be x cubed, du's right there. You're off by 3. So this turns out to be like a 1 over u squared, or 1 over 1 plus u squared. This turns out to be like an arctan problem. But it's in a definite integral. I'm sorry, it's in an improper integral. So you have to take a limit at some point. And so you know that if you're going to do a limit and it's got arctan in it, that means you have to understand, what's arctan of infinity. What is arctan of infinity? What's arctan of infinity? No? Y'all aren't there yet? What does tangent look like? Okay, arctangent of infinity, pi over 2. Arctangent of negative infinity, negative pi over 2. Okay, so in that problem, that came up. Look at the second one. This is an improper integral type 2, right? Notice I'm not telling them what to do, right? I just said do this, right? I'm not telling you what to type 2 or anything. So this right here, you have a problem where? At 0, because natural log of 0 is undefined. So you got to go and do what we just did, but you got to do integration by parts to integrate that. You probably let u be the natural log x, and then you let this be your dv. So that's what I've asked before, and then I'll keep going if you all want me to. This was another semester. Trig sub, you have to look at that 5/2 as being the square root to the 5th power. So that's a trig sub problem. Partial fractions, long division first, right? I did give them just a trig integral. Trig sub. When was this? Spring 2016? Infinite, right? It's infinite, both directions. So you have to do limit. This is a type 1, right? But you've got to integrate this. And to integrate that, you've got to look at that denominator as the square root of all that squared. You've got to look at this as being the square. Oh, wait, no, hold on. No, take that back completely. Take that back. Sorry. You can just complete the square on this. Just complete the square on that right there, and it'll look like 1 over something squared, either plus something squared or minus something squared, and you have formulas for that. This one, partial fractions, right? And then I gave a bonus. Where is it? Boy, everyone's so eager to hang around now. What is this one? Trig sub, right?
Yeah.
Need long division first there, don't you? On that second one? Need long division. You need long division again. Oh, but this is improper. So you might have some zeros in there. So you have to factor out this denominator and make sure. No, I don't think this is improper. I think this turns out to just be definite. Well, how does that denominator factor? X minus 3x plus 2. And so 3 and negative 2. Okay, so we don't have any problems there. So that's just a definite integral. So that just partial fractions, long division first. Here's an improper integral. But you're going to have to do what here? By parts. Ooh, here's an improper integral. This one's improper for sure because at 1 it's undefined, right? And you have 1 in there. Partial fractions? But you have to take a limit at the end. Just giving you a flavor of what I've asked in the past. My main thing is go to your homework. When I make this test, I'm going to sit down, I'm going to look at your homework problems, and I'm going to create them based on that. All right? I'm telling you how I'm going to do it. I'm going to sit down, I'm going to flip the book open, I'm going to look at what I've assigned, and then from that I'm going to pick some problem in there, maybe tweak it a little bit. Right? All right, everyone. Have a great weekend. Guess I'm not taking attendance.